Bismillahirrahmanirrahim. Good morning, everyone. I am Dr. Suhila Kattoush, and in this video, we will study one of the most fundamental concepts in computer networking, communication protocol models. Understanding these models is essential because they explain how devices communicate over a network and how data move from one system to another. Through this lesson, we will explore the OSI model, the TCP/IP model, and the concept of encapsulation and decapsulation. By the end of this lesson, we will be able to explain why communication models are organized into layers, describe the function of the OSI models, understand the TCP/IP architecture, compare the two models, and explain how data is encapsulated before transmission and decapsulated when it reaches the destination. Modern networks are complex. To make communication easier, they are organized into layers. Each layer performs a specific task and communication with adjacent layers. This layered architecture simplifies network design, makes troubleshooting easier, and allows devices from different manufacturers to communicate efficiently. Without a layered architecture, every manufacturer would implement its own communication rules, making interoperability very difficult. By dividing communication into layers, engineer can modify one layer without affecting the others. This makes network development, maintenance, and future upgrades much easier. There are two main communication protocol models, the OSI model and the TCP/IP model. Both models organize communication into layers. The OSI model is mainly used as a reference for learning and standardization, while TCP/IP model is the architecture used in today's internet. The OSI reference model divides network communication into 7 layers. Each layer performs a specific function and provides services to the layer above it. This modular design simplifies network implementation, maintenance, and troubleshooting. Let's briefly look at the 7 layers. The physical layer transmits bits over the medium. The data link layer manages frame and detects errors. Network layer performs addressing and routing. The transport layer ensures reliable end-to-end communication. The session layer manages communication sessions. The presentation layer handles data formatting, encoding, and encryption. Finally, the application layer provides services directly to user applications. It is important to remember that these layers do not work independently. They cooperate to ensure successful communication from the sender to the receiver. Although each layer has a different responsibility, together they provide a complete communication process. Like the OSI model, the TCP/IP model consists of 4 layers. It is the protocol suite used in the internet today. The application layer combines the top 3 OSI layers, followed by the transport layer, the internet layer, and the network interface layer. Both models are based on layered communication, and the OSI model has several layers and is mainly used as a reference model. The TCP/IP model has 4 layers and is the practical model used in modern computer networks and the internet. In practice, network engineers often use the OSI model to analyze and troubleshoot network problems because it clearly separates network functions into several layers. However, when configuring real networks and internet services, they mainly rely on the TCP/IP model, since it is the protocol suite implemented in modern operating systems and network devices. Before data is transmitted, each layer adds its own header. This process is called encapsulation. As the data moves down through the layers, it becomes a packet, then a frame, and finally a stream of bits ready for transmission. During encapsulation, every layer adds its own header containing important control information, such as addresses, error checking information, or port numbers. These headers allow the receiving device to correctly process and deliver the data. At the receiving side, the reverse operation takes place. Each layer remove its corresponding header before passing the data to the next layer. This process is called decapsulation and continues until the original data reaches the application. Each layer removes only the information that belongs to it and forwards the remaining data to the next layer. This process continues until the application receives the original message exactly as it was sent. In this lesson, we introduced communication protocol models and explained why layered communication is important. We studied the OSI and TCP/IP models and learned how encapsulation and decapsulation enable reliable data transmission. These concepts provide the foundation for understanding computer networking. Thank you for your attention. I hope you found this lesson helpful. See you in the next lesson.